Hello everyone. Today we are going to see Module 18 in problem solving using C. Today we are going to talk about C strings. In the C programming language, there is no built-in data type like we see in modern programming languages such as Java, Python or C++. Instead, C represents strings using array of characters stored sequentially in memory. Each character occupies one byte and is placed in continuous memory locations, forming a sequence that collectively represents text data. A string in C is simply a collection of characters used to store meaningful information such as names, messages, addresses, or sentences. Unlike other languages where strings store their length automatically, C identifies the end of a string using a special terminating character called the null character. The null character is written as \0. This design gives programmers more control over memory but also requires careful handling. Now we are going to see about the null character, which is the essential terminator. What is a null character? In C programming language, every string must end with a special character known as a null character represented as a \0. This character has an ASCII value of 0 and acts as a signal indicating the end of the string. All standard string functions such as length calculation, copying and comparison depend on this terminator to know where the string stops. When a program reads characters, it continues until it encounters this null character. If the null character is missing, the program may continue reading beyond the intended memory area, accessing random memory locations. This causes incorrect output, unexpected behavior, or even program clashes. Therefore, the null character is one of the most important concepts when working with strings in C. Now we are going to see how we can declare a string. To declare a string in C, we use character array. The general syntax is the keyword char followed by string name and the array size inside square brackets. We are going to see an example. Char greetings in square bracket as specified it as 15. This reserves space for 15 characters in memory. This compiler automatically adds /0 if you initialize the array directly. Declaring char greeting 15 reserves memory for 15 characters. This memory includes a space for both the visible characters and the null terminator. If the string exceeds the allocated size, it may overwrite adjacent memory, causing errors. Hence, choosing an appropriate array size is very important. When initializing happens during a declaration using double quotes, the compiler automatically appends a null character at the end. Now, now we are going to see how we can initialize a string. One of the simplest and most common used ways to initialize a string is using double quotes. For example, we write character array equals hello. Here the compiler automatically determines the required memory size and adds a null character. Here we have seen the compiler automatically determines the array size, 6 in this case, HELLO and the null character. This method improves readability and reduces program effort because we do not need to manually count characters or add the terminating symbol. Due to its simplicity and safety, this approach is widely used in real-world C programs. Now we are going to see how we can initialize a string. The second method using single quotes. Another method of string initialization is assigning characters individually using single quotes. In this approach, every character must be specified separately, and importantly, the null character must be added manually at the end. As we have seen char message, HELLO and the null character each are included in single quotes. This method provides precise control over memory representation and is sometimes used in low-level programming or when characters must be explicitly managed. However, it is more error-prone and less convenient compared to using double quotes. Now we are going to see pointer declaration. In addition to arrays, strings in C can also be handled using character pointers. A character pointer stores the memory address of the first character of a string literal. For example, when a pointer points to word hello, it actually references a fixed memory location where the string literal is stored. These string literals are usually stored in read-only memory by the compiler. This means we can change the pointer to pointer somewhere else, but modifying the characters directly is unsafe and leads to undefined behavior. So the key difference is string literals are stored in read-only memory. Next, we are going to see about array versus pointer. There is important conceptual difference between character arrays and string pointers. When a string is stored in character array, the data resides in writable memory, allowing individual characters to be modified. For example, we can change letters within the array without issues. For example, here we have declared it as char array hello. If we want to change H with J, directly we can specify array of 0 is equal to J. This string data is stored in modifiable memory. You can change the individual characters. However, when using a pointer to a string literal, the data is stored in read-only memory. Attempting to modify it may result in a runtime error or a program clash. Therefore, whenever string modification is required, using character array is considered safer and more appropriate. Let us see an example. Here, we have included a header file stdio.h, and here the second step we have declared and initialized strings. We have declared a greeting array and we have stored initialized with hello world. And in this third step, what we are going to do is we are going to print using string functions. And the fourth step, we can compile and run up. And whenever you're going to compile and run, you're going to see what is the output and how its behavior is. So in the practical example, first we include the standard input-output header file to access input-output functions. Next, we are going to declare an initialize string named greetings with the value hello world. Then using the printf function, we display the string on the screen. When the program runs, printf reads characters one by one until it encounters a null character terminator, ensuring only the indicated intended message is displayed. This example demonstrates how strings are stored, accessed, and printed in real programs. Next, we are going to see what are the advantages of strings. String offers several advantages in programming. Some of the advantages are easy text handling, supports input-output operations, useful in file handling, used in menus and messages. We are going to see one by one. The first one is easy text handling. They simply handling of textual data and make user interaction possible through messages and prompts. Strings are essential for input-output operations, file processing, menu systems, and data storage. They are widely used in applications such as login systems, data processing tools, and text-based interfaces. Now we are going to have a review about the summary of C strings. The first one is array of characters. Strings in C are array of characters stored sequentially in memory. And there are two ways of initializing strings. They can be initialized using double quotes for simplicity or character by character for precise control. The third one is null terminator. Every string must end with a null terminator which signals the end of the string. String literals are stored in read-only memory, so character arrays should be used whenever modifications are needed. Understanding these concepts forms the foundation for advanced string manipulations in C programming language.